Now, the types of bonds. We have two types of bonds. We have an ionic bond and we have a covalent bond. And when we talk about an ionic bond is not an actual bond. An ionic bond is an electrostatic interaction. And when we say electrostatic interaction, we mean charges. So we have charges between elements that are losing electrons and elements that are gaining electrons. So how we form ionic bonds? Ionic bonds, they are formed whenever you have an electrostatic interaction that happens between groups 1, 2, 3, which is metals, and non-metals, which is groups 5, 6, and 7. Guys, it's not necessarily metals. We can do transition element metals as well. So it's either groups 1, 2, 3 or transition elements, as long as it's between a metal and a non-metal. So if you look, for example, at NaCl, NaCl has a molecular formula. So NaCl has a molecular formula of Na and a Cl. This is called a molecular formula. And the molecular formula shows us how many atoms we have in the molecule. So here I have an NaCl molecule that has sodium. It does have one sodium in it, one atom of sodium in it, and one atom of chlorine in it. Sodium is in the group number 1. So sodium is in the group 1, and the chlorine is in the group number 7, right? So in order for the sodium to bond with the chlorine, because right now they are bonding with each other, in order for the sodium to bond with the chlorine, sodium, I know that sodium has one electron in there, right? Because it is in group number 1. Since it has one electron, it's going to go ahead and lose its electrons, okay? And when it loses its electrons, it is going to become a positive charge. So sodium will become a positive charge. It's going to lose its electrons in there. And at the same time, if you can look and see, chlorine has 7 electrons. So this is 1, 2, 3, 4, 5, 6, and 7. Chlorine is in a group number 7. It has 7 electrons. How many electrons does it need to gain in order to become 8? 1 electron. It needs 1 electron. So it's going to gain 1 electron from where? From the sodium in there, in order to become 8 electrons. So you can see over here, there's a mutual agreement between the sodium and the chlorine. It's a transfer of electrons. So you're transferring an electron from the sodium to that of the chlorine in there. And when you are doing this, the sodium is going to become a plus a charge, and the chlorine is going to be octet. It's going to have 8 electrons in there, and it's going to be a negative charge. See these charges in there? We call them ionic bond. So this is an ionic bond, and when we represent an ionic bond, we represent it as an ionic structure, meaning you have a positive part, you have a negative part. We never, ever represent an ionic bond by a regular bond. Never do this. An ionic bond is an electrostatic interaction that involves a transfer of electron from the metal to the non-metal, because the non-metal will need those electrons. The metal will have those electrons, so it's going to give it to the non-metal, and the electrons get transferred in there. They both are going to have the electrons. So the sodium is going to bond electrostatically with the chlorine to compensate its loss of the electrons. These are considered to be ionic bonds, and ionic compounds, they always exist in 3D arrangement. We call it a crystalline lattice. Here, this is the crystalline lattice of salt. For every atom of chlorine, this is bonded to sodium. But when they arrange with each other in there, they form a 3D arrangement of crystal lattice. Let's have another example. Draw the formula for potassium and oxygen. Okay, again, these are all examples for ionic bonds, because I just want to make sure that I'm working with the metal and the non-metal case. So potassium, this is a metal, and we know that potassium, it is in a group number 1, and oxygen, this is a non-metal, and oxygen is going to be in group number 6, right? So let's go ahead and draw the charges for potassium and oxygen. So I know that potassium is in a group number 1, so it can lose 1 electron, right? And oxygen is in a group number 6, so it's going to gain 2 electrons to be octet. Let's go ahead and draw the formula, the actual reaction where showing the potassium having 1 electron. Potassium loses this electron in there to become K plus 1 electron. So always the metal loses an electron, and the non-metal in there is 1, 2, 3, 4, 5, and 6. The non-metal is going to gain and 2 electrons there. So it's going to gain 2 electrons. So I need 2 electrons. I don't need 1 electron. I need 2 electrons in order to become octet. Okay, in order to become octet with a 2 minus in there. So notice oxygen needs 2 electrons, right? Needs 2 electrons. But potassium only has 1 electron to give. So how many potassiums do I need to use? Actually, I need to use 2 potassiums in there, 2 of them, in order to balance that oxygen. So what I do is you put the charges in there and then you crisscross. So you cross those charges in there. Here you go. You just cross those charges. And when you do, you can have the formula in there. And the formula is going to be K2 and an O. So what does that mean? If I want to draw K2 and an O, the charges have to balance. I know that the O is 2 negative, and I know that the K is 1 plus, right? So what I do is I say 2 plus, 2 minus, the charges are balanced. They are 0. And this is when you draw any molecular formula of any inorganic structure, the charges have to balance out. So the total charge of the molecule to be stable, it has to be 0. And this one is 2 plus, 2 minus, so it is going to be 0. Okay, let's have another example. Draw the formula of magnesium and chlorine. So you don't have to draw the actual reaction showing the magnesium losing electrons and the chlorine gaining electrons, but I'm just drawing this just to explain over here. Magnesium is +2, and the chlorine is in the group number 7, so I'm just going to go ahead and draw the 7 electrons. So it's going to require just 1 electron in order to become octet, to become 8 electrons in there. So I just need 1 electron. I don't need the 2 electrons of the magnesium. I just need 1 electron in there. So this is how I simply draw it. I draw the magnesium with its charge, and I draw the chlorine with its charge. So I say, okay, magnesium is in the group number 2, so it's going to lose 2 electrons. Chlorine is in the group number 1, so it's chlorine is group number 7, so it's going to gain 1 electron in there. Now I know that the charges are not balanced. I want to balance them, so I simply cross them out. I simply cross these charges in there, so I cross them. To balance them, I need to crisscross them, and then the formula now becomes magnesium, Mg. That is going to be a chlorine, and the 2 is going to be there. So when I cross them, see this 2, it becomes to the chlorine. And this 1 over here goes to the magnesium. You just need to skip that. You don't have to say Mg1. So you just say MgCl2. Let's go ahead and double check that to make sure that the charges of the MgCl2 are 0. So the Mg is 2 plus, and the chlorine here is negative, and I have 2 of the chlorines. So it's 2 minus and 2 plus, and the charges are going to be 0. Guys, the chlorine is a non-metal. And this is always the case of metals and non-metals. So this is a metal in there. Whenever a metal combines with a non-metal, what I'm going to end up having is an ionic bond. So this one is going to be an ionic. It's going to be an ionic bond. So if I give you the structure of MgCl2 and tell you what type of bond is there between the magnesium and the chlorine, it's actually called an ionic bond. For every 1 magnesium, there's 2 chlorines that balance it. So if I want to draw it, it's going to be like this, Mg2 plus, and then around the Mg, I have 1 chlorine, which is negative, and then another chlorine, which is negative, if this makes sense in there. So this is how the charges balance, 2 minus, 2 plus in there. This is an ionic interaction, and it is not an actual bond between the Mg and the chlorine. Ionic bonds are very, very strong bonds. These are very strong interactions. It's kind of like misleading when we say an ionic bond. It's kind of like an ionic interaction, but we call it an ionic bond. The interaction is very strong with these types of molecules there. Aluminum and the chlorine, you guys. Aluminum is a metal. Chlorine is a non-metal. Okay, so aluminum is a metal. Chlorine is a non-metal. We are gonna do the same thing in there. I'm not gonna draw the reaction, so you already know aluminum is group number 3, so it's gonna lose 3 electrons. The chlorine is in a group number 7, so it's gonna gain 1 electron in there. Okay, the charges are not balanced, so I'm just gonna cross the charges out, and the structure is gonna be an Al, and it's gonna be a Cl and a 3. Let's double check in there if we want to double check and make sure our charges are right. The aluminum has a 3 plus, the Cl is a 3, and each Cl has a negative charge in there. So the charges are balanced, 3 plus, 3 minus. So whenever I'm looking at the AlCl3, this means that for every aluminum 3 plus, I do have 3 chlorines around it, and each chlorine is negative 1. Okay, this is a chlorine, and this is a chlorine as well. The formula between aluminum and oxygen. So aluminum, we said that aluminum is going to be a plus 3. Oxygen is going to be in group number 6, so it needs 2 electrons to become octet. So it's going to gain 2 electrons in there. I'm going to go ahead and cross the charges out in order to put the formula down, and that is going to be Al2O3. Okay, Al2O3. So let's go ahead and double check that. Always double check your answer. Make sure that you are fine regarding the final charge of your molecule there. So the 3, this is negative 2. Yeah, so see, it is 6 plus, 6 minus. Charges are the same, plus minus, so they cancel each other. This is a revision from the other chapter, but here I'm relating it with the ions. I'm relating it with the ions. So please remember that a 1 mole of the sodium chloride, that corresponds to 22.9. This corresponds to the molecular weight of the sodium plus the molecular weight of the chlorine. So you go ahead and you calculate the molecular weight of the whole molecule in there. We can relate this also to the number of ions in there, because I know that NaCl is made up of Na plus ions and Cl minus ions. How many? Since I'm working with a 1 mole of the sodium chloride, then that is 6.023 times 10 to the 23 ions of Na plus 6.023 times 10 to the 23 ions of the Cl minus. Doing the same example over here, but now the aluminum oxide, they do have coefficients. So you have 2 aluminums, you have 3 oxygens in there. You calculate the molecular weight of the aluminum oxide. The molecular weight is 2 times the molecular weight of aluminum plus 3 times the molecular weight of oxygen, and you get this number. That corresponds to, pay attention to your coefficients in there, because you do have 2 times the 6.023 times 10 to the 23 ions of aluminum 3 plus 3 times the ions of the oxygen 2 minus in there. Okay, we can relate the Avogadro's number to the number of ions. We can relate it to the atom in there. We can relate it to the molecule. We can relate it to the whole molecule in there. So, but here I'm relating it to the ions and to the atoms. So this is another conversion that we can also use to calculate the number of atoms of oxygen and aluminum in the aluminum oxide molecule. When we talk about isoelectronic is a term that we use whenever the atoms or the ions they have the same number of electrons. Okay, so for example, if I say neon 10, neon has a zero charge, so this 10 is considered to be the atomic number, right? And the atomic number is the same as the number of protons, and it's the same as protons, number of protons, and it's the same as the number of electrons as well. So we said that if you have an atom and or an element that has a zero charge, then in this case, the number of protons are equal to the number of electrons is equal to the atomic number. So neon here has 10 electrons. Just you can go ahead and draw them, and this is 10 electrons in there. So neon has 10 electrons. Now, if your atom or if your ion in there, if your atom becomes an ion, so if the atom becomes an ion, then it's going to either lose or gain. Here I have magnesium. Magnesium lost two electrons. It lost them from where? It lost them from the total number of electrons. It was 12 whenever it was a zero charge. Now it is 2 plus a charge, so it has to lose two electrons from the 12. So it's going to become 10 electrons in there. So now magnesium has 10 electrons. See, magnesium has an atomic number of 12. When it is 2 plus, it's still atomic number of 12. The number of protons is equal to 12. It didn't change, but what changed is the number of electrons. The number of electrons is a 12 minus 2, so it's now equal to 10. So for ions, please pay attention to this. For ions, the number of protons will not change. It will stay as same as the atomic number, but the number of electrons always changes, and it's going to be the subtraction between the atomic number and the charge. So please pay attention to that. In case it's a plus a charge, in case it's a negative charge, you have to add. So for example, if I'm working with an oxygen that is 2 negative, and I know the atomic number of oxygen. Let me go scroll over here just to see the atomic number of oxygen. Oxygen, I think it is 8. So oxygen is 8. Okay, so here we go. So oxygen is 8. So if I am working with the number of protons, that is 8 for oxygen. The number of electrons for the oxygen is equal to 8 plus 2, and that is equal to 10. See the difference in there? With magnesium, I subtracted because it was 2 plus. So let's have another example. For example, aluminum. Aluminum 3 plus in there. So for aluminum, let's take a look at it's 13. This is its atomic number. So over here, okay, so that is going to be 13. So the number of protons for the aluminum is equal to 13. The number of electrons for the aluminum is equal to 13 minus a 3. See the difference in there? Not 2, minus a 3 in there. So it's going to be equal to 10 electrons. Okay? The number of neutrons is going to stay the same. The number of neutrons is equal to the atomic number minus the mass number in absolute value. Number of neutrons is always positive. Okay, so number of neutrons is always positive in there. So this is regarding isoelectronic. This means that the atoms are they have the same number of electrons. So the atoms or the ions, they have the same number of electrons. Here, this one has 10 electrons and the other one has 10 electrons as well. So I would say that magnesium and the neon, they are gonna be isoelectronic. So I would say that Mg2 plus and neon, these are isoelectronic. They have the same number of electrons. So as a summary, when we look at ionic bonding, we see that ionic bonding represents a transfer of electrons, not sharing, transfer, meaning that the metal lacks electrons, or the metal gives the electrons to the non-metal. in there. So you can see that the electrons are being transferred from the metal to the non-metal. And this is the definition for ionic bonding. Covalent bonding now it is different. Covalent bond is an actual bond, and we represent it by an actual bond. We draw it by an actual bond. Remember, ionic bonding was electrostatic interaction. So we represented it by simply drawing the plus and the minus charges. Like, for example, when we were drawing, let's say, for example, aluminum chloride, we said that you draw the aluminum, which is a 3 plus, and around the aluminum, you do have the 3 chlorines in there. And we would say that there is an electrostatic interaction between the plus and the minus. So for every 1 atom of the chlorine, you do have 3 atoms of the, sorry, for every 1 atom of the aluminum, you have 3 atoms of the chlorine in there. So this is an electrostatic interaction. Covalent bonds are different. Covalent bonds, they are strong bonds. But which one is stronger? Of course, the ionic is a stronger interaction than the covalent bond. But for covalent bonds, these involve sharing of the valence electrons to reach 8 electrons. So the 8 electrons are being shared by both atoms in there. How do you form covalent bonds between what and what atoms? These are between non-metals, between carbons and hydrogens. The carbon is a non-metal, hydrogen is a non-metal, between a carbon and any non-metal in the periodic table, or between atoms of the same type. We call them diatoms, like F2, Cl2, H2O2, N2, and so forth. Okay. So, for example, this is the reaction in there showing how the covalent bond is simply formed. So you start with the fluorine. I know that fluorine is group number 7, right? So it has 7 electrons. You combine it with another fluorine that has 7 electrons in there. So what happens here is that fluorine has 1 electron here that bonds with the electron here. So these two bonds, they are being shared. They are being shared because we know that fluorine lacks 1 electron. So it's going to take it from this fluorine here. And this fluorine lacks 1 electron. So it's going to take it from this fluorine there. So both of them are going to share a pair of electrons. And both of them now, if I want to count the total number of electron of the fluorine, I would say, okay, fluorine has 8. This one has 8. So both of them are going to be octet. To represent this bond in here, we represent it as a line. Every bond is 2 electrons. So this is called a covalent bond. It's an actual line that you draw between the two atoms. Let's have another example. Hydrogen. So hydrogen is a non-metal. So if you combine two hydrogens together, this is not an ionic bond. This is a covalent bond. So the electron of the hydrogen will bond with another electron of the hydrogen. Guys, hydrogen does not follow the octet rule. Hydrogen has only 1 electron and it can accept another electron. Why? Why? Because if you look at the hydrogen is 1s1, right? So its total capacity, it has 1 electron, and the s orbital can accept another electron to be completely full. So hydrogen has 1 electron and it accepts another electron in there. So I'm going to form my covalent bond between the hydrogen. So this is called a covalent bond. So by definition, to form a covalent bond, I need to form a covalent bond between two nonmetals, between a carbon and a nonmetal. So whenever you see a carbon, carbon in most of the cases, 99%, it makes a covalent bond with hydrogens or with nonmetals. Okay, so let's have an example. So what do I have here? I do have a nonmetal and another nonmetal. Do you see? Two nonmetals in there, so definitely this one is going to be a covalent bond, and this one is going to be a covalent bond. So what type of bond I have here? I do have a covalent bond. So this one is considered to be a covalent. Both bonds are covalent bonds in there. Guys, these bonds, we call them sigma bonds. These are called sigma bonds, and they are covalent bonds. Between a carbon and the hydrogen, a carbon is a nonmetal, a hydrogen is a nonmetal. Between two nonmetals, we have a covalent bonds. So all of these bonds that you see over here, all of these bonds, these are considered to be covalent bonds in there. Nitrogen is a nonmetal, oxygen is a nonmetal, oxygen is a nonmetal. All of those bonds are considered to be covalent bonds. When you make a double bond, always a single bond is a sigma bond. The first single bond is a sigma bond. The second one is going to be a pi bond. There are two types of bonds in there are two types of bonds in chemistry, which is the sigma bond and the pi bond. The sigma bond is a single bond. The pi bond is a double bond. Okay, so this one over here is going to be a pi bond, but the type of bond here is going to be covalent bond. Same thing between carbon and oxygen. Carbon is a nonmetal. Oxygen is a nonmetal. Oxygen is a nonmetal. So all of these bonds that you see over here, these are considered to be a covalent bonds. The first bond is the sigma, the first bond is a sigma bond, and then the second one is a pi, and then the second one is a pi. Whenever you see double bonds, meaning two bonds above each other like this, the first one is considered to be a sigma bond, the second one is going to be considered a pi bond. Now, NaOH. So what is NaOH in here? See, when you look and see that your molecule starts with a metal, okay, sodium is a metal. It's a group number one in there. Immediately, it's an ionic bond. So there is no bond actually between the sodium and the O. It is an electrostatic interaction. So I would say between the sodium and the O, this is an ionic bond. Why it's an ionic bond? Because the Na is a plus a charge. The OH, we'll talk about it as we proceed. It is one group on its own and it is a negative charge. This is called sodium hydroxide. But the bond between the oxygen and the hydrogen over here, because these are two nonmetals, this bond is a covalent bond. And here, this is an ionic bond. Okay, so the bond between the oxygen and the hydrogen, this is covalent in there. So can we have a structure that have both ionic and covalent bonds? Yes, we can. We can, and you need to know to separate them, how to separate them from each other. Always when you start with a metal, then this, whatever the metal is and whatever comes after the metal, this is going to be an ionic bond. It's not necessary that everything in there is going to be ionic. No, because these two are non-metals. So this is why it is a covalent between the O and the H. Same thing in there. The sodium is a plus a charge. For every positive, there is a negative charge in there. So for every positive, there is a negative charge just to balance the total charges of the structure. So that is going to make this thing an ionic bond. Okay. And then, of course, between carbons, hydrogens, and oxygens, all of those are considered to be covalent bonds. How did I know that this oxygen is a negative charge? We will talk about formal charges later in this chapter, but see, the charges has to balance. So if this is a plus a charge, then everything that is basically bonded to the sodium has to be negative so that it can balance the charge of the sodium in there. So we would say that sodium is the metal counter ion. It's the positive counter ion that balances the negative charge of the oxygen. So this is an ionic bond, and everything else connected to the oxygen is a covalent bond.